No chalk. Morning. Whoa, what happened? Well, at least you're getting around, so is it just a sprain?
I don't know what it is. Yeah.
You gonna have it looked at? Good morning. Good morning. Here's some stuff for you guys. I handed back. So come on up and grab alphabetical. Chelsea's there. Antonina's somewhere here. Here's one.
Part of it.
Probably. Hello, and let me know who you are. Morning, Earl. Okay, Louisa, I need your buffer capacity lab. So we did that one kind of together. Aiden, I need that as well.
Oh, I have that at home because it's in my notebook.
That's fine. Just bring it on Wednesday.
Okay.
I think you were there, Aiden, when we did that.
It's the one we did
You
last
weren't
time.
there. Okay.
Was that Clem and Ruth because they actually got
Let me give you a copy, Aiden, so you at least know what we did, okay? Errol, I still need your buffer capacity lab too. So see if you have that. Lola, I need yours too, buffer capacity lab. You weren't there. All right. And Chelsea, I need yours too, your buffer capacity lab. See if you have that. Here's a copy so you know what we did. Okay, morning, Penelope, morning, Ellen. And Bella is at home. Hello, Bella. Okay, so Bella, I need your buffer capacity lab. You can email it to me. Chelsea, I talked to. Feeney's not here. And Sophia, I talked to. Errol, I talked to. Mina's not here. Ellie, I need your metal cations lab if you have that. So see if you have that. It was acid-base properties of aqueous metallic cations. Louise, I talked to. Penelope, I need your buffer capacity lab too when you get that far. Okay. Alex, here's a file for you. You can grab that. Okay, so welcome everybody. Here's what's up today. We're going to finish chapter 7. We're going to take your questions and plan our time for the rest of the course, as it were. Great, thanks, Bella. So, when last we met, thank you very much, super. When last we met, we were talking about oxidation and reduction. Let's kind of balance one just to remind ourselves how to do it. So I'm going to say, and I better get some data to do this. Hopefully I can quickly find a table. There it is. Okay, so here we go. No, that's not it. I need some numbers. I need some voltages, and then I'll have you try one. There's some. Okay, so here's the question. Oh, Amina's there as well. Okay, and Oscar. Good. Okay, so, Oscar, if you have the buffer capacity lab, email it to me. Amina, same thing, buffer capacity lab. Exactly. Okay, good. Thank you all. All right, so let's get this in the middle so you guys can see at home as well. And before I forget, Earl, here's a okay, so folks, write this down. All right, let's try and do it. So what do we got? We got two equations, and I'm letting you know it's a voltaic cell. A voltaic cell means the thing does what? What does that mean if they say a voltaic cell? Folks at home too, what does that mean, voltaic cell? It does, yeah. Penelope. Thank you. So it gives off energy. So its voltage better be what sort of value? Anthony? Positive voltage. So we're looking for something with a positive voltage. And I've given you typically, these are called reduction half reactions. That's what you get on the AP. But of course, what do you got to do? And Sophie? Say again? We need the polling too, but what we'll have to do is one of them for sure. I'll have to do what with it? Let's see. Flip it. I'll have to flip it because I got to get one reduction and one oxidation, right? So there's both reductions, okay? By giving you this in words, tell me which one you got to flip. And Sophie. Yep. So if I flip it, let's just put a line through this. What do I mean by flip it, Chelsea? What do I got to do to write it then?
Switch the reactants in color.
Do so?
Oh, QB for QB2 plus is QB minus. And I think the voltage becomes positive.
Good. So now I got plus. Now this is a pretty easy one. This is a pretty easy one because the are already balanced. What's got to be balanced that's already balanced here? What's got to be balanced that is balanced, Chelsea?
Yeah.
The electrons. There's 2 and 2 and they drop out, don't they? Good. Give me, Arrow, give me the rest of it. Read off what I got for my redox. So I got to put it together. What's my redox reaction? Put together what's left.
I2 plus plus Y
I need the rest of it. What's it, Aiden?
plus 2B
So I need from both, Arrow. Okay, Forms, what else here? Okay, thanks, Aiden. Aiden, while you're there, can you give me the voltage now? What would the voltage be?
we just add them.
Uh-huh.
It would be 7.
Thank you. Okay, so see what we had to do? So that's a skill you've got to know. It's usually harder. It's usually like 1 electron and 4 or 2 and 4. And then you got to multiply like in math class to make the electrons cancel out, right? So be aware of that. But that's just to get your brains, I think, warming up, I hope, on a Monday morning. Yeah, thank you very much. Ah, Feeney is there. Okay, thank you, Feeney. Good, I wonder where you all were. Okay. Thanks for participating. Okay, appreciate it. I'll try to look down more so I see what you're saying. Question, Anne-Sophie.
This is like, if, for example, where I like the 1 electron form one, I minus.
No, it's got to be I2.
No, but would you have to multiply everything including the voltage?
No, that's a good question. Really good question. Let's say, folks, that we had to do what Anne-Sophie is talking about. Let's say we had to multiply this whole equation by 2. Do we multiply the voltage by 2? Answer starts with an N. Okay? We don't. No. Why? Because the voltage is representing the fallen energy of electrons. It doesn't matter if I got 20 falling or 2 million billion falling. The fall is the same amount of energy given off. I know it's in volts, it's not in joules, but essentially it's the difference in energy is what we're talking about. So no, we'd never multiply that by anything. We did have to flip it as Aiden did because I changed the reaction and turned it around. So I had to change the sign on the voltage. Okay? Okay, let's see if folks at home have any questions or comments too. Exactly, Bella. Because I think this one I crossed out. I mean, I just put that up there. That's what you originally would get. You got it? Okay. All right. So, okay. There we go. Good. Questions from anybody on how to do this sort of problem? Okay. We're going to jump into now stuff towards the end of our chapter. and that is relations between voltage, which is E0. I'm sorry, they don't just say V, but they don't. The voltage is E0, or electrochemical potential is another name for it. Delta G. And delta H, no, K. We kind of did this before break, but it's so fundamental, I want to make sure we got it. Spontaneous, non-spontaneous. Okay, an important review little document here, right? Okay, how about Lola, pick one. Voltage, delta G, 0 if you want, and K, or K, any of the three. When is one or the other spontaneous or not? What sign or what sort of number do I have? Can you pick one and tell me about it? How about voltage? We just did voltage. It's spontaneous when? Okay, good. And non-spontaneous when it's? There you go. You got one done. Anthony. Super. And non-spontaneous, of course. Who can do K? Who can do K? How about Alex? I haven't talked to Alex yet. Or somebody at home. Could you do K? Alex, see if you can beat him. So K is what sort of number if it's spontaneous, what sort of number if it's not spontaneous. Or if somebody at home can beat Alex, do it.
I'm not sure.
No? Okay, K is a equilibrium constant. We talked about that a lot this year in different chapters. One person knows. Let's see if anybody at home has it. Not yet. And Sophia, you're on. No, it's not positive or negative. Not for K.
Oh, no, it's not.
Yeah, louder.
Last one.
Which one is which? For spontaneous, it's greater than 1. And of course, it's less than 1. Okay. You guys really got to review this. You're going to do a lot of reviewing anyway. But remember, we said this was 1. If it's bigger than 1, I get lots of products. So make your arms do that, right? Bigger than 1, lots of products. Remember, it's products over reactants. You know that. If it's less than 1, then it favors the reactant. So we say that's not really spontaneous then. Okay? All right. Well, yes, Bella had it there. Good, Bella. Okay, let's then talk about some physical relations here with equations. Did it blow away or do I still have it here somewhere? You need that one. Because then you need this one. Let's just list them. So for these three things, voltage or electrochemical potential gives free energy or just free energy, and the K, the equilibrium constant. How do you transform one to another? Very carefully. And with these reactions, here's one. We're going to learn how to use them today. Delta G equals negative N times F times E 0, and the other one is E0 equals 0.0257 over N times natural log of K. Ta-da! And there's actually kind of a third one too. Oh, let me think of that. So I got G to F. So I need another one that goes, I got E to both of them. So I need delta G and K. Okay, I better look back for that one. Actually, I'm going to ask Alicia. Alicia, do you remember the one, because I'm concentrating on this chapter, that relates delta G and K? Exactly. And that's what I want to find. So if you find that chart, let me know what page it's on. She's got a nice chart. I'll give you the page as soon as one or the other of us find it. 509, thank you. I was almost there. Okay, so page 509. Everybody turn to that, okay? And she's got a cool triangle. And the third one has to do with changing delta G and K. So it was the rat length one. That's what Cheryl calls the rat length, right? Rat, RT, length. And don't forget the tail on the rat, right? That's a negative sign, so a little tail on the rat. So easy one to remember. So those three will help you with this triangle, right? Let's label them. 1, 2, 3. Okay, so check them out. Anthony, give me one that changes 1, 2, or 3. What changes the voltage to if I do it correctly, K, voltage to K. Which one, 1, 2, or 3?
Uh,
Number 2. Okay, which one, Louisa, which one changes delta G to K? 3. So obviously that one's going to be 1. Good. So those 3 will be given to you on the given information on the AP. But finally, you're going to use them often enough, especially in this chapter. You're probably going to know them anyway, and you probably should to save time. Okay. We're gonna. This one we've used before. I'm not gonna do the rat length one because we've used it, but we'll do 1 and 2 right now as some practice. Okay. And those guys can't see that, so there that is. Essentially, folks at home, we just did what's on page 509. So if you got 509, you got that little triangle there. Okay. Some stuff you need to know. E0 is the standard voltage. Or electrochemical potential. Just so you know where they got the E from, okay? All right. F is a new idea. We haven't had this before. F, you might have had it in physics, it's called the Faraday constant. And it's this. Why don't I like it? Oh, because it's in that. It's 1 mole of electrons has 90. Oh, I don't want to do this. Yeah, I'll do it this way. 9.648 times 10 to the 4th joules per volt. So it has to do with an amount of energy that's contained in a bunch of electrons. Why are we talking about that? Because we got flowing electricity, right? Like Penelope and I think Anne Sophie said earlier. That's what this chapter is about. It's flowing electrons, it's electricity, so I really have energy to deal with. And Faraday's constant is just how much energy am I getting from a 1 mole of electrons that's flowing. N is really similar to what it was in Pivner. So Alex, what was N in Pivner?
Number of moles.
Exactly, it's the same here. This time it's the number of moles of electrons that are transferred. Like at the beginning of the hour, we had +2 electrons. Well, it'd be like 2 moles of electrons would be transferring to make PB2 plus PB. We'll use all this right now, and you get an idea what to do. Okay, we can skip that. Oh, sorry. So let's say you got an equation, and you can tell it's a redox because I've got signs changing, right? 0 going to -1, -1 going to 0 charge, so definitely a redox. Plus, they give you a voltage for it anyway. Okay, so how about Aiden, check out the top board. So which reaction, 1, 2, or 3, is going to help me do this thing? I want the delta G for this redox reaction.
1.
1. So let's rewrite it so we can use it. Okay. You can do it the long way, but you can also usually be clever about it. Okay, gang, look at the numbers, especially the redox numbers in this. How many moles of electrons is being transferred? See if you can figure it out just by looking at what's happening on each side. One person's got it already. Let's see if somebody at home can get it. How many, so we're looking for N. How many moles of electrons are transferred in this reaction right here? I got a second, maybe? And a third? How many moles of electrons were transferred? Okay, 80?
Well, would it, to the whole equation, would it just like cancel each other out.
They would, but before they cancel each other out, I mean, like how many electrons are going to be given off on one side and taken in on the other side? That's what I'm talking. How many are actually transferred? One, no, Errol.
Nope.
Two, why two, Errol?
Because BR is like there's two BRs are negative and then there's two that are not.
So essentially, I'm going from 2 minus, you know what I mean? Because I got two negatives, and I'm going to 0. So those are giving off 2 electrons. And over here, I'm going what? This is 0, right? And I've got 2 minuses. See what I'm saying? So without doing, I could do the whole thing over if I needed to. If I'm really just still waking up, I could go, okay, well, this is Cl2 plus 2 electrons makes 2 Cl minus. And the other one is 2 Br minus on the other side makes Br2 plus 2 electrons. I could do all that, but I'm trying to save a little time, especially if I have this on the AP test. So I just want to look at it and say and here's a negative sign, so I'll leave that, 2 moles of electrons. Okay? Good. F we know, so it is. And I better just make sure, I think I got to have in joules. Let's just make sure which one I'm doing. I got in my notes kilojoules. Oh, that's why. That's why you do it. Okay, all right. Well, let's just sort of look at it. Give me this value. How about Ellie? Give me this in kilojoules. What would I have to do with this sucker? Good. Well done. So she's right. 96.48 kilojoules, right? Divided by 1,000. So she's done that mentally. Joules per kilojoules per volt. Let's do that now. Why? Because ordinarily we want delta G to come out in kilojoules. So let's kind of do that version of the F, right? 96.48 kilojoules per, and it's actually per mole volt, because the mole is going to do what here? Cancel out. So should have to be a smart guy. Let you know. And here I kind of have it in the phrase, so I'll leave it there. Okay, and the voltage you were given, 0.283 volts. Okay, so wake up and grab your calculator. Yes, Amina, that was right. Thank you. Okay, good question from Amina. She says, do we multiply the F also by 2 because I got 2 moles of electrons? No, you don't need to, Amina, because the 2 moles of electrons is already in this N number. That takes care of it right there. Okay, give me a value, folks, at home. It's all delta, standard delta G. And then let's see what we get. Antonin, what'd you get? Okay, let's see if that checks with others. 54.6. Good label on it, going to end up being kilojoules. Thank you, Maria. Probably, well, we could say per 2 mole of electrons. Let's just call it for the equation, you know. So that many kilojoules. Okay, and notice it's negative, which makes sense because the reaction should be, Alicia, spontaneous. So because the voltage was positive, so that sucker is going to happen. It's spontaneous. Beautiful. Okay, questions on that? Okay, let's use the other one. Let's use the other one. Okay, find K. For PAG solid plus NO3 minus aqueous plus 4H plus aqueous forms 3Ag plus NO gas plus 2 waters. Okay, let's see if they can see that. Yeah. So this time I kind of have to do what? It's a bit more complicated. They don't really give me anything. What do I got to look up or find? Hint, I'm looking up in the chapter on redox. I got to get what at some point? The voltages. Thank you, Penelope. Exactly right. So, for example, I'm looking on page 473, and because your book doesn't have them all on that page, I'm going to go to the end of the book. And I'm hoping, hallelujah, there they are. They're in a appendix. So on page 523, you're going to look up, please, the voltages. So just as Penelope said, we need to get the voltage. So look for the parts, please. So let me know on page 523 if you got an equation that might be half of this. Remember, we're looking for two halves, either forward or reverse, and then tell me what it's going to be. Did you find one already, Anthony? Question.
Would it be wrong?
It's a good question. You could do the whole thing different if you were given delta G values, and you could find that first, and then use the equation that does delta G and K. You can use the Ratlink one. So yes, you could do it that way, but you'd have to be given all the data, which they won't do. If they want you to do this method, Anthony, they're going to give you the voltages to do it. Okay, so you're going to be given them now by me. It's at the end of that. Look for silver, look for the other stuff. You should find two equations there. Chelsea, you got one.
Yeah, for NO3 minus plus 4H plus. There's 3 electrons.
Okay, NO3 minus.
Plus 4H plus. And then plus 3 E minus.
3 electrons?
Yeah.
Okay, keep going.
That forms NO gas plus 2H2O.
Okay, looks like Chelsea's found one. Notice even the number of waters matches, which is nice. Okay, then the other one. I need it from N sub V.
The other one is EG plus EG plus.
Beautiful. Okay, there's my two reactions. I need two other things too. So I need from both these ladies, I need their voltages. So give me the voltage, Chelsea, for this one that you had here.
0.96.
0.96 volts. Okay, and the one from Ann Sophie?
0.80.
Good. Now I had several hands up. So what's the deal? We're not done. What did we notice, Alex?
We have to multiply the volume equation by 3.
Yes, but something else too. Check out what we're building. Before we multiply by 3, we probably better do something else. One person sees it and another. Alicia? Yeah, because the AG plus is on the wrong side, isn't it? So look carefully at what we're building. AG solid. Oh, that's how you know. So take it, whoop, flip it around, rewrite it. And now what happens to the voltage Anne-Sophie gave me? Ellie, it's going to become negative. So I'm going to put a minus sign in front of it to remind me. Good. And then someone else said we had to do what with this sucker? Alex said it. Alex, what do we got to do with this thing also? Okay, so it's just like in math class. We got to make something drop out, the electrons in this case. So 3, 3, 3, and look at those, they drop out, life is good. And don't we now build this? And do I need to write it again? I really don't, right? But importantly, I need to get the voltage. So gang, what do we got? We got negative 80 plus positive 0.96. Gonna be, Anthony? You got it. So it is it a spontaneous cell, folks? Is it a spontaneous electrochemical cell? It is, it's positive. I know it's not a big number, but it's still positive. It's gonna happen. Huge. Now over to Errol. Equation 1, 2, or 3, Errol, if I'm looking for the K value. 2 is right. So let's write it. So E0, 0.0257 volts probably divided by N times natural log of K. Okay, let's throw in our voltage. 0.0257. Hey folks, look at our half equations. You might say, Mr. Weiss, why do we have to do that? We could have just added the voltages. Kind of had to help us. Why? Because we need to know N. What's the N number if you look at the two half reactions now? Louisa, how many moles of electrons are transferred? 3. Yeah, that's why we had to at least mentally do that. So divided by 3 moles of electrons, okay, times natural log of K. Okay, now comes some math we got to fuss with, right? So I'm going to erase the board and finish up the math. Let's see if folks at home got it. Nope, they're doing okay, I guess. Okay, so straight from algebra class, right? We got to get the natural log of K in one spot. So we're going to flip the bottom and multiply it over. Times 3 moles of electrons divided by. Remember, math-wise, anything on the top on one side ends up on the bottom on the other side, right? Just divide, boom, multiply, boom. Because I want you to be able to do your algebra pretty quick to save time. And Sophie. Okay, I got one other algebra question before I take a number from you. How do I get rid of this natural log thing? Math folks, what do I got to do? Answer me. E to the x. If you haven't had that in math class, they kind of cancel each other out, natural log and e. So for you, you're going to take all of this to the e power. Okay, so figure out all that to the e power. And then can you everybody do that, including folks at home? And let's see if we all get the same thing for K. Well, you tell me, should it be bigger or smaller than 1? Bigger. Why, Anthony? Because the voltage was positive, right? And, well, that's all we got. It better be bigger than 1. Okay, so what do we got? Lola, you there yet? Okay, let me know what you get when you get there. You can check then with others. Are you? Okay, so you may have to put in like, do 0.16 times 3 divided by 0.0257, get a number. And then all of that is going to be your e to the x button. Sometimes you got to put it in before, sometimes after you hit that e to the x button. No, I doubt that, but we got to figure it out on your calculator. They all give the right answer eventually. And Sophie, what'd you get? Well, I need to remember. Can you put it scientific? So. What'd you get, Anthony? Let's see if that checks with some others. Is that what you got then when you counted it out? Others we got the same? We did Penelope too. Thank you. Good. Okay, so try it out, Lola, again until you get that number. You should be able to figure it out. Again, sometimes you got to put it in on the calculator before you do the e to the x button, sometimes after. You got it. Okay, all right, good. So it's a big number because it's a voltage that's greater than 1. It's a voltage that's positive. So the K is much greater than 1. It's really, really big. Okay. You got the same. Thank you, Feeny. Yeah. Good. Okay. Okay, this sounds like a complicated question, but it's going to end up being no big deal. What if non-standard concentrations are used for electrochemical cells? Okay, the standard is 1 molar for solutions of 1.0. And if it's a gas pressure, can you guess the standard? If it's a gas pressure? Errol? You got it. Okay, so all of that's kind of outside. Okay, so now you know what the standards are, okay? Well, how do you figure out if it's not standard? What happens? Use the Chatelet's principle, which is essentially going to be logic. Let's do the example. Well, let's do the one we just did, okay? All right, so effect on B if 0.010 to the -0.4 HCl used in. And then we'll fill that in a sec. Okay, we'll do that right after break. Take a break. We're doing good. Yeah. If you got your book with you, let me know and I'll grade it. I still need to grade chapter 1. Ellie, if you got chapter 1, I could grade that in your book. And who else do I need? Lola, if you got chapter 1, she already left. Feeney's not here. Bella's not here. Okay. When you guys come back at home, I need to grade your books at some point. And if you're not coming back, we'll have to do it after the AP test, okay? But I'll need them at some point to grade them. You got it there for me? Thanks, sir.
Do I need these two? I don't know why I don't have them. Oh, yeah, the other labs also don't.
Yeah, they should. They should. Calculated pH for buffer 1 or 2. Should be the same, shouldn't it? Just read it again, but I think logically it should be the same. And yeah, they should have something. Some of these folks aren't here, but I assume they got the right in there. Let's see. Oh, the indicator. Okay, it should. Errol, the indicator was like the initial color. Like because it's this color, it's about this number. You know what I mean? So what color was it to start, and therefore it was about what pH? Okay, they give a number.
4.5.
Okay. Super. Thanks, sir. The clausuramine is on everything. Book 1, book 2. No, the clausur's on everything. I can't change that because I have to prepare you for the AP test, which is on everything as well. So it has to be on everything. And it will be. We'll be done with everything by the end of the day today. So that's the scoop. So you're gonna have to everybody put some wheels on and really get rolling and do as much as you can of all the chapters before the clausura on the 21st and before the AP test on May 7th.
like, let's go through everything, like every assignment. You had to do, and like make sure that no one's like,
And then, I was like, okay, see if I can ignore him. He emailed the same damn thing to my parents.
yeah, I'm like,
He emailed my parents and he was like, yeah.
and I was like, it's not COVID, but thank you for your, like, you know, like, trying to reach out, like, thank you,
My parents sat me down and they go, so how come you got this email for us and why?
literally saying, so,
Like, yeah.
It's like, what do I say? My doctor's one day, he was like, Ellie, can you tell me what's wrong? And I'm like, what do you mean? But you got to know one of your teachers, can you tell me who it would be? And I'm like, I don't know. I'm like, I don't know.
One of the great things about my parents is they're very straightforward. They don't sugarcoat things.
I mean, I don't either, but they just gave on purpose so that I would like, come to work there. Yeah.
Yeah.
So like, you know, like, your project was fine, but like, but it's just,
I know Lord of the
Okay, here we go. Okay, so here's the logic. You ready? Again, all this sounds complicated. It's not. Assume that, well, not assume. If it's standard, everything's 1 molar. That's the solutions. You ready? Let's find it. NO3 minus, that's in a solution. That's 1 molar. H plus, that's from an acid. That's a solution. Ag plus, that's 1 molar. That's a gas. So I don't care about that. And water doesn't matter at all. I'll be with you in a second. The only one that says they're changing is this. So instead of 1 molar, I'm going to put in 1.0 times 10 to the negative 4th molar. Is that bigger or smaller? Smaller, way smaller, right? So now you're going to mentally think. K was products over reactants, right? K was products over reactants. Therefore, I'm putting in something that you guys just said was much smaller on the reactant side. What's that going to do to K? I'm putting in then a really small number here. Is that right? No, that's not right. Why doesn't that work out? Hold on. I'm saying something, but it's not true then. That put in a small number should be bigger to it, doesn't it? Ooh, I can't think about that way. Why doesn't that work? So products over reactants should be my equilibrium constant. Equilibrium constant. No, I can't do that. Okay, forget that. Somehow that's not working. Somehow that's not working. Let's just use the Chatelet's principle instead. Okay, so it was 1 molar. Now I'm going to change it to 1.0 times 10 to the negative 4th molar. So if I change it to that, something really small, which way the reaction is going to have to shift because of making something really small here? Question first, answer P. Oh, thank you. 3 of them, right? Thank you. Okay. Okay, which way the sucker gonna have to shift, Chelsea? Towards the reactant. So if I make this really small, then remember, that's like digging a hole. Remember how that was when we talked about Le Chatelier's principle? If I take something out, if I make this small, then the reaction's gonna shift. Well, maybe I should do it this way. To try and replace that. What do you think? Is that going to make the voltage more or less because of that? So what will happen to the E minus, or the E0, the voltage?
Would it be negative?
Well, I don't know about that, but what will it be? What sort of number compared to the one we had? We erased it, whatever it was, point something something. It'll be smaller. I want you to really think about that because I want it to be logical to you. Let me tell you where we're going. The AP used to have you calculate out how much bigger or smaller, an actual number. They don't ask you to do that anymore. But they're still going to ask you, like on multiple choice, a logic question about this. So let me give you my quick and easy way to do it. Okay, ready? Voltage increases if the concentration of the reactants increases. And voltage increases if the concentration of the products, can you guess what? Decreases. Exactly. Good logic. So let's do the second one and just mentally think about it. We did the first one, right? Actually, we didn't do the first one. We did the opposite of the first one, didn't we? We put in a smaller concentration, and of course, the voltage decreased, went down. Let's first do the opposite. Let's, instead of 1 molar HCl, mentally, everybody, think of putting in like 4 molar. 4 molar. Somehow putting in a lot of this stuff. And which way is it going to shift? Towards the Penelope? Towards the products. Exactly right. So if I put in a lot more than 1, it shifts towards the products. If I put in less than 1, it shifts towards the reactants. Ellie. If the concentration of the reactants increases, didn't I write that? Yeah, the voltage will increase. But I did with you, the first time I did it with you, Ellie, I did the opposite. I said, what if I make it go down? And so then it would decrease. So the voltage goes down. And let me just write if H plus concentration equals 4.0 molar, voltage goes up. Okay. So in other words, you're not going to have to figure out by how much, but you guys are going to have to mentally kind of work out which way the effect will happen. Okay. Yes, yes? Let's see if I got any other questions from you or from the folks at home. None so far. Okay. All right. Okay, now. I hate this word because it doesn't sound any different than electrochemical cell. But an electrolytic cell, okay, you ready for this? This is something that, frankly, you gotta, this is my crappy English definition, you gotta put in electricity to make the cell run. In other words, the voltages are what, gang? Two people know? In other words, the voltages are what? You got to put in electricity and make the sucker run in. They're negative voltages. You might say, well, what, Mr. Weiss, why would I want to do that? Well, because you want to get something. Here's the big use for these things. The big use for these is to get metal. To get metal. And I mean like solid metal, like aluminum, like iron, from ores. When metal's in ores, it's usually in some sort of like ion form. Okay? And here it's going to be a pure form. Another use is electroplating. For example, if I pull out my keys or your keys, most keys are covered with a hard metal. Okay? I don't know what it's made of, but often they're electroplated to something that's even harder. Okay? And something that doesn't come off as easily as maybe whatever they're made of, iron or whatever. Okay? So electroplating is like an outer coating of metal. That's the main place we use electrolytic cells. So let's talk about how to do it. The process is called electrolysis, which means put in electricity to make the redox happen. So electricity put in to run the redox reaction. We're going to answer some questions about this, and a lot of the rest of this unit is about amounts, okay? So, how much is made? Let's do an example here. Sorry about that, folks at home, pardon me. Let's do an example here. Ag plus an electron forms Ag solid. So 1 mole of electrons forms 1 mole of Ag. This is an actual physical amount. If I look up the molar mass, it's 107.9 grams. So that's what I'm saying. So if I pump in enough electrons, and I know this is only a half reaction, obviously something else is happening too. But if I can pump in enough electrons to make my Ag positives go to Ag, I can get a piece of silver out of it, silver metal. And that's what they do to get silver. Well, we don't really talk about moles of electrons in the electricity business. We talk about coulombs. So you might have had this if you got it physics, but now you're going to have it in chem. You haven't had it, don't worry, it's no big deal. A coulomb is a big number of electrons. Okay, so 9.648 times 10 to the 4th coulombs. Is that right? 6 coulombs is 1 mole of electrons. And we kind of had that already. It was called 1 Faraday. It'll be given on the AP test, that number, okay? That's 1 Faraday, 1 Faraday. Okay, Faraday's a mole of electrons. Ute. We need that conversion. Okay, here we go. Let's do an example. Cr metal can be electroplated. By the way, that's how they do like old-fashioned chrome bumpers on cars. They got to electroplate the chrome onto the bumper and make it look nice and pretty and shiny. So chromium can be electroplated from an acidic solution of CO3. And here's the reaction. H plus 6 electrons plus CrO3 forms Cr plus 3H2O. Now I'm giving you the half reaction because frankly we need this number of moles of electrons. You'll see how right now. Okay, so first off, how many grams of Cr from 1.00 times 10 to the 4th coulombs. Now, I kind of hate this, but we're stuck with it. The abbreviation for coulomb is C. It's stupid because that's also for Celsius and some other stuff, but we're kind of stuck with it. So you should know that that big C means coulomb, okay? Okay, you ready? So, let's do it. Start with the amount of coulombs. This is like the amount of electrons you got. We got to change it to electrons in a second. So 1.00 times 10 to the fourth coulombs. Okay, so who's following? How can I change it to moles of electrons? Chelsea.
1 mole of electrons over 9.648.
Thank you. Exactly right. There's your conversion factor, as we say in chemistry. So other than that, the rest is pretty easy. Okay. Then we say what? Okay, I need 2 moles of electrons for every mole of, what am I making? Chromium, right? Okay, look at the reaction. How about Ellie? Point out this reaction. What? How many moles of electrons for how many moles of chromium? Beautiful, good. Look where she got those. There's the chromium, there's the electron. So now we're just pulling it right from the equation. And then we just got to change what, folks? Moles to grams, because they want the amount. So can you look up the molar mass, somebody? I don't know what it is. 53? 52 point what? 0.0, thank you. Good, and punch that out. Let's see what we get. Folks at home as well. Okay, let me know what you get, somebody, when you get there. I notice everybody without a calculator, stuff cancels, and I should end up with just grams of CR. Antonine, what you got? That check with others?
Yeah.
It does, thank you. So not much, just less than a gram. But then that's what you'd have on the back of a key or something, you know what I mean? It wouldn't be much to make a key, or probably a lot less than that on a key. A key to look shiny. Okay, I call that part A. We're going to use the same reaction and do something with part B. Part B. If a current of 6.0 amps, and now I got to tell you what an amp is. You ready? Okay, 1 ampere is 1 coulomb per second. Oh, okay. So don't be afraid of amperes. It's just telling you how many electrons you got. Okay, if a current of 6.0 amps is used, how long will it take to plate out, that's how they say electroplate, plate out 1.0 gram of CR? Okay, now, at this point in the course, you probably realize chemistry, so much of it is all about labels. Even if you got new weird stuff, just kind of crank through the labels and the rest will follow in place. Trust it. Trust the process. So I want to get how long What do you suppose they're looking for at the end of the problem? What sort of label, Alex? Like in seconds, okay? And notice I got something in seconds, so I'm going to be able to get there. Let's start. Okay, I got to go 1.0 grams of CR. Probably, gang, I got to change that to what first? Arrow? Change it to what? It's in grams. What do we always change it to? Change it to what? And so, Penelope. To moles. I'm going to change it to moles. So I'm going to go grams to moles. And I think Chelsea already looked that up for us. So what is 52.0? Good. Then I got to use my equation. Kind of look at what we did with this other one, right? Oh, we got a relation here. Look at that. Moles, and I want to get to, I got to figure out for the moles of CR. So what's over what? Chelsea? You got it. I got moles of CR, so that's got to cancel. See what I mean about following the labels? It'll lead you there. Just keep plunking away at it. Okay, and it's the same ratio, but upside down, isn't it? So I got a mole of that, and I need 6 moles of electrons. Where am I getting that? From the equation. Same equation. 6 moles of electrons, right? We got from Ellie earlier. Okay, same 6 moles here. All right, we're getting there. I got to get to coulombs and seconds. Well, I can do the electrons. What's the relation there, Penelope?
Would it be second?
Yeah, it would. We're going to get that, Penelope. It's 1 down. But I got to get something else first, Lola.
You put 9.648 for coulombs over 1 mole electron.
Exactly. Thank you, Lola. So she's getting rid of moles of electrons. And now we can do what Penelope said, right? Now we can do, she said, seconds over coulombs. And I said it's 6 amps. 6 amps, so the 6 is going to go where? So an amp is a coulomb per second. So the 6 is going to go, and Sophie?
1/6.
Thank you. So 1 second over 6 coulombs. Whew. Okay, you ready? Grime it out. Didn't it? So I told you it would work. And you just keep multiplying. The labels will eventually crank out. Let me know when you get there how many seconds you got. If it's really big, we may want to turn it to minutes or something. Okay, Jesse, you got it? You got a question or you got it?
I got it.
What is it?
1,855.
1,855?
Yeah.
That's the same? Let's divide it by 60. Can you guys? How many minutes would that be?
Basically 31 minutes.
31?
30.9.
Right, okay. It's about 31 minutes. Thank you. Yeah, great. See what I mean? Trust to the process. Crank through labels. Labels will guide you there in chemistry a lot of the time. Okay, as you're catching up, I'm going to see if Cheryl bothers with this or not. If she doesn't, I won't. Because she writes the AP test. She's one of the writers for the AP test, by the way. That's why I follow her so flippin' closely. Because she knows what she's doing. Good. She says yes. So we're going to do this one. Okay, so let's do a little C. Okay. Its voltage is 4.5 volts. How much energy in joules is needed? for 1 gram. Okay, what you got to know for this is as follows. Energy is voltage times the coulombs. Okay? So for this one, we can kind of just do it partly. So energy is what we want. And energy, everybody's in what sort of label? We measure energy in joules. So we want this in joules, okay? And it will come out that way, okay? Okay, we need voltage times coulombs. Our voltage, did I give you that? I did. So 4.5 volts times coulombs. Did I have coulombs? Yeah. And look at the last problem, Alex. Really, we just need the last problem, but how far? How far do we got to use that, Alex?
Up until we go to second, so basically stop at the 9.648.
Beautiful. So, okay, can I take this and just drop it in down here? Can we do that? So, ready? Here we go. 1.0 grams. Thanks, Alex. Times 1 mole CR over 52.0 grams times 6 moles electrons over 1 mole CR times 9.648 coulombs divided by 1 mole of electrons. Yeah, is that a pain? Kind of, yeah, but if you do it all within the problem, then it saves you some time, doesn't it? So I'm going to let you guys crank that out, and folks without a calculator can help me get rid of some labels. So I get coulombs times volts, ta-da! And that's going to give me energy. So it automatically comes out in joules. And you guys can crunch that out and let me know how many joules that is. Ellie, you got it? 1.11 times 10 to the fourth. Does that match with others?
Is that the coulombs or is that the energy?
Well, that's the coulombs. Go ahead and crank it out times 4.5 as well, Ellie.
What was that number?
Good. And then Ellie, you got what?
5.0.
You got it. Ten to the fourth or fifth? Which is fourth? Okay, that sounds about right. Good. That many joules. Good. Good. Huge. Last topic, last new thing of the entire year. Rust. Only because it's so important, because it happens all the time. I got Fe2 plus 2 electrons, and that's a voltage of 0.409. And then I got half of O2 plus water plus 2 electrons forms 2 OH minus with this, and that is 0.40. One. So I get 0.810 volts. And gang, that's really a high voltage. No wonder rust happens so easily. Let's run the numbers. Let's see what's left. So rust is iron plus oxygen plus water makes Fe2 plus 2OH minus. Essentially, this makes FeOH2, which is rust. Okay? First thing, I know you're still writing. I know I'm pushing you today. This first thing, is it oxidizing or reducing? What's the top reaction? Fe going to Fe2 plus. Oxidizing or reducing? One person knows. It is arrow. Reducing. Going from 0 to 2 plus. Is that getting smaller? Second guess, arrow. Oxidizing. It's getting a bigger number. 0 to 2 plus. If it's getting a bigger number, it's oxidizing. So that's my oxidation. And that happens at the anode or cathode. Who remembers the thing? Anode or cathode? Hint, they both start with a vowel. Happens at the anode. Okay. I'm just doing this to review, okay? And of course, then this is reducing. Let's see why. So reducing is, it's gaining electrons. So check that out. So that's how I know, arrow, that it really is reducing. Even if I don't check the oxygen, but if it's going from 0 here to whatever it is, and there, probably 2 minus, it's also going to a lower number. So that's reduction. And everybody, it happens at the cathode. Remember, cathode and reduction both start with a consonant. I know it's stupid, but it works. Oxidation and anode both start with a vowel. Good. Look at the reaction. What's one way I can prevent rust? There's more than one answer. What's one way I could prevent rust? What could I do with something? And Sophie? Don't add water. Keep it out of the rain. You got it. What's another thing I could do to make it so something doesn't rust? There's many answers here. What else could I do? So don't let it get wet. Or, Penelope? Get rid of the oxygen. Have it in an environment where it doesn't have oxygen. So I got a chunk of iron. What could I do to get rid of the oxygen? Something simple. Ellie? I could vacuum seal it, yeah. Or something even simpler. In a container, yes. Even simpler than that. What am I doing? You just paint it. That's why boats are painted, folks. Iron boats are painted. Why? It's to keep out the water and the oxygen, to keep it from rusting. Makes sense, right? Or they're coated with zinc, for example, or something else to keep that from rusting. Yeah, Anthony. Yes, that will as well. As long as I electroplate it with some other metal, right? Like chromium or whatever. So one reason originally they had chrome bumpers on cars was not to make it look cool, but to make it so it kept out the oxygen. Yeah, and the water. Good. No. So, my people, with 3 minutes to spare, let's talk about the rest of the year. I'm happy to be done with that. So normally I finish the last chapter before break, but with Corona, one day off, that wasn't too bad this year. So what we're going to do the rest of our time is a number of things. One is I'm going to do review stuff with you between now and the clausura, and I'm going to do a full AP test with you. So we'll take, maybe not Wednesday, but maybe Thursday. I'll have you guys do like a multiple choice test for, I got to decide if I want the full hour and a half one, or maybe I'll just have you do half of one. And then we'll grade it and work on multiple choice strategy the following day or the following period. That's what I'll do. I'll have you do a half one this year. And then maybe the following week we'll do an essay test and then grade it in the period 2 and see how we do on that, okay? Because I want you ready for your clausura on the 21st of April. Questions, comments so far, Alex?
Are these grades just now, let's see where we at, or going into the grade book?
That's a good question. Are these going to go, when we do practice stuff, is it going to go in the grade book? No. That's why it's practice. Who's up? I think it's 1 through 4 probably, or 1 through 5. I got to look and see, but it's that 21st of April day. So I'm guessing it's the first few hours in the morning. Alex.
Are we gonna have any other grade assignments? Anything that goes not working?
Yeah, what we'll have is I'm going to eventually grade all the chapters in your book too. So my best advice to you is grunt through and get book 2 done. Okay? And then as soon as you finish, start working on review stuff. I'm going to give you things in class. Plus, in the AP classroom, you've got all those review problems that they have you do. I've opened up all of them for you. You should work on those. And please consider joining what I sent you an email about, that AP review session, because it's run by national, wonderful, great AP Chem teachers who are probably ones that help make up the test itself. And I think that'll be a really useful session. It's free. Just sign up for it. Louisa.
I have a question about that. Because I looked at the time, it's 7:30 or 8 in the morning. Do we stay home and do the session, or do we come to school?
Well, is it 7:30 their time or our time?
I think we're
I think their time. So it's going to be then 6 hours later.
okay.
So it'll be afternoon. And if you got a class and we can manage it, I will try and get you excused from that class.
And,
Okay?
is it like a Zoom call, or is it like a video?
I don't know. Has someone else looked into it that far? I don't know. I'm guessing it's going to be some sort of either Zoom or Google Meet or something so that people can interact with it, with the teacher or the professor at the other end. But I think it's going to be really useful. I urge you to do it. And Sophie?
I think it's Zoom, because they have like the two and ask questions.
Okay, so Zoom would certainly work for that type of process. Good. Right. How many of you in the classroom, and maybe folks here too, how many of you have signed up for the May 7th date for the AP test? 1, 2, 3, 4, 5, 6. Okay, 7. All right. And maybe some of you at home as well, you can let me know. If you sign up for the May 7th date, that's fine. I mean, if you're not taking it at all, that's perfectly okay. You know, I'm still going to prepare you as if you were taking it because it'll help you prepare for your clausura, if nothing else, okay? But I just want to know how many I'm kind of getting ready for the test then the first week of May. Good. And what other stuff, Alex? We'll probably do, because we've run so short of time this year, we'll probably do a couple labs after the AP test. I wish I could have squeezed them in before, but I don't know if I'll be able to do that.
Does that mean?
And those will be graded, like titration lab we haven't done, and a couple others that are kind of fun ones that I may have you do, and we'll grade those too.
Does that mean we're done with the test? Or like this small test?
Yeah, folks, after the AP test, you are done taking tests for me, period. You'll have done the clausura, you'll have done an AP test. Will it just be labs and whatever else that we figure out we want to do this year?
So that means if I'm not taking the clausura this year because I'm taking 2 others.
That's fine.
And I'm not taking the AP now.
Okay.
So then my only grade is.
Your grade is going to be all the chapters in the book and lab stuff that we do later on, Alex. Yep, okay. Super. Thanks, folks at home. Okay, so I see. I think you would have already signed up, Oscar. You'll have to contact the counselor about that, or talk to your classmates about it. And Bella signed up. Okay, thank you. Okay, we'll cut it right there for today. It's a good spot to stop. See you for Wednesday for review. Goodbye, and Sophie. See you tomorrow. See y'all. Thanks for coming in.